Dear children, in the previous video, we tried to understand how to write the electronic configuration of a given element. Say for example, if oxygen is given, the atomic number of that particular element is we know. So, we know how to write the electronic configuration, how to assign the electrons in different subshells, I mean in the different orbitals S, P, D, F like that. Now, so here today let us learn how to write the configuration of an element in different shells. I mean how to assign or how to accommodate the electrons in the different shells. We know that there are 4 major shells K, L, M and N. Okay. So, to write the electronic configuration in detail, so that we have understood, writing 1s2, 2s2, 2p6, 3s2 like that we have understood. But there is one more way of writing the electrons, that means assigning the electrons in the different main shells, that is the main energy levels, that is K, L, M and N. So, now let us see the first one. For example, we have taken carbon, right? The atomic number of carbon is 6. Okay. Now, what is the electronic configuration or how these electrons have been arranged in K, L, M and N shell? You know that children, the maximum number of electrons present in the K shell is, that is 2, right? Now, how many electrons left behind? There are 4 electrons, correct? You know the maximum number of electrons which are present in L shell, that is the value of N is given by 2, that is 2n square, means 2 into 2 square, that is 2 into 4, that is 8. So, therefore, what is the number of electrons left over now? Out of 6, 2 have been occupied in the K shell. Now, the remaining 4 electrons, they go to the main shell L. Hope you understood. So, therefore, the electronic configuration of carbon can be written as 2, 4. That means 2 electrons in K shell and then the 4 electrons in L shell. Okay. Now, come to the sodium. The atomic number of sodium is 11, correct? So, now, what is the number of electrons in K shell? That is 2. So, here in the L shell, maximum number of electrons, as I have written there, 8, correct? This is 8. Okay. Now, what is the remaining number of electrons? That is 1, that is 2 plus 8, 10. So, actually it is the atomic number is 11, therefore, 1 electron remained, that 1 electron goes to M shell. Okay. That means the electronic configuration of sodium can be written as 2, 8, 1. Did you understand? Okay, let us see one more element, that is aluminum. Okay. Here also the same thing, K shell gets 2 electrons, L maximum number of electrons 8 and then 8 plus how much? 2, it is 10. Now, where the rest of the electrons goes? There are 3 electrons. So, these 3 electrons, they go to M shell. Okay. Now, the electronic configuration of aluminum is said to be 2, 8, 3. Okay. Hope you have understood. Now, let us go to an interesting aspect now. Let us see the electronic configuration of potassium. Now, see here, observe the atomic number of potassium, it is 19, correct? Now, as you know, K shell will have 2 electrons and L shell will have 8 electrons, 10. Now, there are 9 electrons remain after these 2 shells got filled, right? Now, what is the number of electrons present in M shell then? Okay. If it is 9, okay, 2, 8, 2 plus 8, 10, it is 19. Is it correct? Children, the way of representing like this, it is absolutely wrong. Okay. So, never the M shall get 9 electrons. Why, sir? Why it is so? Now, let us try to write the electronic configuration in detail. Okay, it is 1s2, 2s2, 2p6, 3s2, 3p6. Okay. Now, we should follow the above principle. Now, it won't enter into the 3D orbital. 3D orbital, it is very big one. The energy is very high. So, therefore, following the above principle, the electron, it goes to the next higher energy level, that is 4s. So, therefore, the electron get filled in 4s. Okay. So, that means, so here it is wrong then. What it should be? Now, one electron, it should go to the n shell, that is the fourth shell. Then, what is the number of electrons in the third shell? This is the third shell, 3s2. There are 2 electrons. Then 2 plus 3p6, 8. Okay. So, now the electronic configuration of potassium is said to be 2881. So, this is the electronic configuration of potassium. Okay. So, this is how the electrons get arranged in potassium. Now, come to iron. See here, the configuration is, the atomic number is 26, right? Now, let us write 2, of course, it is 8. Sir, what is here now? Is it 8? Because you have written here 8. Okay. Is it 8? 10 plus 8, 18. The rest of the electrons, will they go to here? No. Let us see how the electronic configuration will be. It is 1s2, 2s2, 2p6, 3s2, yes, come on, 3p6, okay, and then 4s2, right, 10, and then 18, okay, 20, the next orbital, that is 3d, how much it is? 3d 6, okay. Now, observe here, what is the, now, first shell, it is having 2 electrons, second shell, so this one, 2 plus 6, 8 electrons, right. Now, let me leave this one, observe the fourth shell, that is fourth shell, it is having 2 electrons, correct. Now, it is 28, correct. 2 plus 8, 10, 10 plus 2, 12. Now, the rest of the 14 electrons, see here, which are those 14 electrons? See here, 8 plus 6, 14. So, 14 electrons, it will come here. So, now, the electronic configuration of iron is said to be 2, 8, 14, 2. So, this is the way how will you represent. Now, let us go to the next one, zinc. Okay. The configuration, the atomic number of zinc is 30. Now, once again it is 2, 8. See here what happens. So, this becomes 10 here now. Okay. 4s2. After that one, 3d 10. Okay. So, now it will be 10 plus 2, 12. Now, the electrons, the remaining number of electrons, it will be 18. Okay. M shell will have maximum number of electrons. Hope children, so this you will understand how to write the electronic configuration or how to assign or accommodate the electrons in the main energy levels or the shells. This is another way of representing the electronic configuration. Hope you have understood this one. Try with a few more elements. Okay, so that I am going to give you in the next class. Thank you.